class. So this is the last lecture of the semester. This is for the quiz over Unit 9, and I'm going to lecture through chapters 14 and 15, so you are prepared to take the last quiz. Let me share my screen. We'll start with chapter 14. More about quasi-experiments. How exciting. Because there's always more to learn about quasi-experiments. Like, what's a quasi-experiment? So if you have lack of random assignments, that's probably an indication that you have a quasi-experiment, right? Because really the big basis of true experimental method, right, is that you have random assignment. We're eliminating all these biases. And so everyone has an equal chance of being in the control group or the experimental group or the pre-group, post-group, whatever, right? It's all randomized. But in a quasi-experiment, we can't have random assignment. It's because you're maybe looking at some behavior or something that would make random assignment impossible or unethical, right? If you were looking at individuals and their memory loss and those that were in car accidents and those that weren't, it would be unethical to take a group of people and put half of them in car accidents and half of them not, right? You cannot go intentionally involve someone in a car accident to get memory damage, right? But you can get a group of people who already have memory damage and a group of people who don't. So it's experiment like, it's a quasi experiment. So it could be a pre-test / post-test design where a behavior is measured before and then you do something and then you measure it afterwards. So maybe these are people with memory difficulties. You give them this pre-test on memory and you do this um, treatment thing that you're really excited about. And then you give them this post-test and you see if their scores change. So you can compare those scores and see a change. And if there is a change, you can't be like, oh, I'm going to throw a party. I've found the cure for Alzheimer's, right? You can't conclude that your condition was the cause, but we need to look at it again, look at it deeper, right? Test, retest, true experimental method. So if you were looking at the effectiveness of a smoking cessation program, maybe people just didn't smoke as much in the post-test because you had been talking to them about, how bad smoking is. And so maybe it's the cessation program that you implemented, or maybe they're just on high alert that day because they know that you're asking them about it. But in a week or two, they're going to go back to their normal baseline. You can create a control group to deal with alternative explanations. So although you can't do random assignment, right, you could have your control group where you didn't give the cessation program to, and you can kind of see, well, did their scores go down too? So maybe it was just that we were talking to them about it in this week-long study and they were on high alert and knew we were analyzing how many cigarettes a day they had or things like that. But the pre-test, post-test design with control that wasn't randomly assigned might just have non-equivocal groups, right? Because there are these group differences, which is what you needed because you're testing this certain thing. But because you can't control it with random assignment, the group differences might make it a non-equivalent group. So if you were studying student achievement in low income elementary students, maybe the issue isn't that schools with low income or low scoring students are more likely to receive funding for their students. The issue could be sorry, reading is hard. Issue could be that schools with low scoring students are more likely to receive funding for studies. So looking at low income elementary students, that might be difficult. And then here's some pre-test, post-test stuff in your textbook if you want to look at that. So maybe if you got that high test or high score in your post-test, maybe it's because there's this extreme score and students were already closer to the original mean at the beginning and all these other variables that maybe we didn't think about. Also, maybe if participants are tested twice, there might be some sort of bias on the testing effect. So I gave them this assessment and then I did this thing and now I'm giving them the same exact assessment. This idea called testing effect, right? People's brains are really good at adapting and figuring things out and trying to be a step ahead. And so it might just be biased because They've already seen these questions before. A Solomon four-group design is a method that evaluates the testing effects in pre-test and post-test design. And so it's this way to see if there are these effects on the post-test scores for all of the groups. But I had an example here. So for example, if you had this four-group design, one group would take the pre-test and the post-test. One group would only take the post-test to compare with the subgroups of the other groups. And then you would be able to compare all of the subgroups, and it's just a way to kind of break up these pieces into more varied or testable, I guess, scores. So you can see if there was this testing effect. For some measure scores, it might fluctuate over time. Depending on what you're measuring, that might just be something that fluctuates, right? Your behavior or your attitude, right? You were stuck in traffic and running late to get to this experiment. So your attitude isn't what your baseline might normally be. You were just really frustrated that day, right? Behaviors and attitudes change week to week, day to day, month to month. Also, time series designs account for this by measuring several times before and after treatment. So if you can do it multiple times and then before and multiple times after, we might get a better idea of that individual's attitude or behavior. Patterns of the scores are compared to determine if there's a difference. Like, are Americans more depressed when a Republican or a Democrat is president? So you could look at it for the whole year, right? If there's no difference, the patterns would be similar, right? Maybe during the election months, people are at extreme ends. People are really happy or they're really depressed. And then we get a couple of years into it and people have kind of mellowed out towards the middle. And then we get to election season again and people are really angry or really happy. And so to really be able to tell that, you wouldn't ask it one time in January of an election year, right? You would ask it repeatedly, the same group of people for about a year, and then you would compare all of those scores together to see if there was a difference or not. An interrupted time series design has an independent event that researchers can't control. So like when everyone had to stay at home for COVID, right? That wasn't anything that we could control. It's not like psychologists could go out there and make people stay in their houses, but we couldn't predict this event, but now that it's happened, we could study it. A non-interrupted time series measures behavior over time before and after this controlled treatment, like maybe the effect of a new therapy on depression, right? We would have to have measured the symptoms before and then after therapy. Researchers have to be cautious when we interpret relationships, right? We need to make sure that we're interpreting it correctly and that there really is a relationship there, and maybe do random assignment because that's more likely in time series designs. You can get random assignment usually that way. Traditional data analysis is often inadequate when you're looking at time series designed quasi-experiment. So historical events can be experienced by large groups or personally, right? You could be talking to one person about their experience on September 11th, or we can be talking about all of Americans, right? Declining economy, loss of a loved one, right? We can talk about it in groups, how generally when people lose a loved one, ... Or you can talk to an individual on their loss of their loved one. So we could minimize these history effects if we had a control group. Maturation is the source of bias that occurs when people naturally change over the course of a study. So the people that you were studying over this source of time or this length of time will have changed anyway. So remove your experiment, but people just evolve over time, right? They naturally change. And so when you're attributing this change to your study or your experiment or your variable, it could be an error if it's just maturation. Like maybe people in depression study get more hopeful. Well, they might have gotten more hopeful anyway. Because if we have a control group though, and we see if they get more hopeful without this treatment, then we can really see, was this because of maturation or is it because of my treatment? Attrition is also a problem, right? It's called mortality sometimes when participants drop out, and that's unavoidable, especially if a study takes longer than an hour or two, or it's a 2-part or 3-part or a month long or a year long, right? You're just going to have people who don't ever come back and you never hear from them again. So in long-term studies, you might start out with an N of 300 and end up with an N of 120. So that data has to be deleted. Those people did not complete it. Those individuals did not finish the data. Your data is not complete, so you just delete their data line. Also, people who drop out clearly have different characteristics than people who like stuck it out for the year. So maybe their condition was worse and they didn't want to talk about it. Or maybe their condition wasn't as bad and they didn't think they needed it for the year. Or maybe they are adventure takers and they wanted to move on to the next thing, or all these variables that we don't know about and that we can't control. But something indicates that these people finished and these people didn't. So these people have to be different. Some participants in a depression study might not return for the post-test, or if you don't know why people didn't come back, it's kind of hard to figure out, well, was it individual difference? Was it a life circumstance? But again, if you have a control group, you can see, well, even 30% of the people in my control group who don't have depression also didn't come back. So it couldn't have been a depression factor or blah, 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 right? There's way more information if you have a control group to kind of test things against. And then let me share chapter 15. I know I just left you on the edge like a cliffhanger. More about other specialized designs. So that was all about quasi experiments. And then here's some other special designs, right? We've done all the normal stuff, correlations and experiments and naturalistic observations, and we made it into quasi experiments. So what about some others? Longitudinal designs. We treat age as a within subjects variable. So maybe we are, looking at this group of people over this long period of time. We wanted to look at the social withdrawal of children who were adolescents during COVID, right? So maybe researchers have reached out to these kids who were in first or second grade when everyone got sent home for COVID, and they're going to follow these kids through high school and see if there was any social withdrawal or differences. Some disadvantages: takes a long time, right? You can't speed up a kid getting from first grade to senior year. It's going to take as long as it's going to take. And the attrition and mortality on that is probably going to be a lot more than a simpler survey or a simple experiment, because you're going to have to keep track of these kids and these families for 12 years. And then testing effects, right? You're asking these kids these same or similar questions every fall and spring for 12 years. So there's going to be some testing effects that probably occur. Cross-sectional designs take less time than the longitudinal designs. So instead of looking at that one group of first graders and their social withdrawal and how they dealt with that through high school and senior year, if you did a cross-sectional, you might look at first graders that were sent home during COVID, and fifth graders and 10th graders and 12th graders. And then now that we're back in school a little bit, look at some others. But now you have these 4 slices or these 4 sections. And so you can't say this is how this kid aged throughout this process, but you can say 6-year-olds seemed similar or different than 10th graders because of whatever differences you found. Some disadvantages of that is there just might be generational differences or generational effects, right? Someone who's in 12th grade just isn't in the same generation as someone who's in first grade, typically, usually the way the generations split, or they had a complete different, childhood or growing up, or their parents were millennials or whatever this difference might be, right? Gen Z is not the same as millennials and so on. And so cross-sectional is nice because you can look at different ages at the same time, but you can't always say it's COVID affected different ages differently, because maybe it was also parenting and it was how they didn't have tablets when they were in first grade, but these first graders do have tablets, so they already knew how to do this or whatever, right? Insert all these other variables here. Cohort sequential designs treat age as both a between subjects and a within subjects factor. So begin with your separate samples of your age groups, and then they're tested multiple times as they developed. So you could look at decline in motivation for math in high schoolers and how that developed or something like that. It also allows for comparison of ages quickly, and maybe generational effects are less problematic or less, they're affecting it less in the cohort sequential designs. So the baseline measurements determine the rate of the behavior before the intervention if you have a small N design. So maybe typically, right, we want an N of 30 or more. If you have an N of less than 30, then we don't really count that data, right? But you might have one single case design. You might be looking at this individual and it's just an N of 1, right? And so maybe you have this baseline measurement. You did all these tests and assessments on this individual. You did this intervention, and then you're going to give them some other tests. That would mean your goal is probably to describe this really specific behavior and how it occurs and how it's occurring, and then change that behavior for that individual or maybe a really small group of people that you're helping treat. Research is typically testing a theory about how certain behaviors work in most people or treatment from a problematic behavior, right? If you have a small N experiment that you're working on, it's probably one of those two questions. So we could accomplish some things through repeated measurement, like discrete trial designs have one or fewer participants compete in a large number of trials. And then you have your baseline designs where you compare the repeated measurement of the baseline behaviors to the behavior after the treatment. And then you can compare the data that way. Some advantages is you get a large number of observations. So that reduces error in the data because you have more data points to look at. But a small number of participants makes it easier to control for extraneous factors, right? If you just have 5 people, you probably can control for a whole bunch of things that you couldn't control for if you're giving this survey to 200 people. But disadvantages, you might not be able to generalize it, right? If it just worked with this group of 5 people, well, maybe that's not generalizable to the entire population. And it's not appropriate for all behavior, right? Some types of behavior abnormalities can't be studied that way. There's also this idea of carryover effect, like sources of bias can occur when this participant experiences their treatment condition, and that affects their later behavior in a second baseline condition that follows for the treatment condition, right? And there's this carryover effect from condition to condition. And so maybe the results that you're getting aren't authentic. What about discrete trial designs? So some of the earliest psychology studies used discrete trials. Ebbinghaus conducted studies of memory processing using himself, right? The forgetting curve. Let me test this and see if I memorize this group of words now in 30 minutes. How many can I remember in 2 hours and in 5 days? We don't typically want to test on ourselves, right? But Skinner did, Ebbinghaus did, Weber did. And so it's not terrible, right? There's a place for it. You can do it with a few participants. It allows for a good test of causal relationships. And it's usually just for like basic processes, psychophysics, learning, like the first example, right? Memorize this list of words. How many can you tell me? Rote memorization, like that's a pretty easy thing to look at that way. Here's some examples in your textbooks if you want to take a look at those discrete trial design examples. Some baseline designs involve comparison of the baseline behavior and then the behavior with treatment. So nothing's done, right? Let me just look at your baseline, give you this treatment, and then see if the desired change occurred. That's typically what school psychologists do, right? The child is being reported to have done this behavior, you test them. Now we're going to try this treatment, see if it works. ABA design is also called reverse design to see if the baseline behavior appears again after the treatment has ended. So in an ABA design, you'd have condition A is first taken, then condition B is implemented, then the behavior is measured again, and then with the treatment, and then finally another baseline is measured, A, taken after the treatment's been stopped to see if the baseline behavior comes back or if that change was more permanent. ABAB design is where the treatment's implemented a second time. So all that stuff I just said, except then you get the treatment again after the second baseline assessment. If you want to analyze your data for small n, you still need to present the data for individual participants. Inferential stats can only be used if you have a large number of observations collected. And it's common for researchers to report mathematical descriptions of the behavior, right? We want t-tests, we want p-values or f-stats, or we want something, we want a Pearson's R. We want to have something that's mathematically saying, here's this difference that we saw and it was significant or was not significant. So everything you ever wanted to know about any other type of research you could possibly do related to psychological behaviors. If you have questions, reach out to me. Otherwise, you should be good to use this lecture and your textbook to take the Unit 9 quiz. That's all. That's it for the semester. Great work.